And this lesson is about converting to different bases. And so within different fields of study, you would be converting to different number bases, meaning counting using different number of digits. And so our base system is base 10, so that means we have 10 different digits, 0 through 9. And then once we get past 9, then it's a combination of what we've already used, like 1, 0, 1, 1, 1, 2, and so on. So this is going to show us how we can take a number in a different base and convert it to base 10 and vice versa. Some of the more common places that you would see this is with computer systems. They use base 2. So they just have 0 and 1 as their two digits that they use to count. We also use base 60 all the time, and that's with time because there's 60 seconds in a minute and 60 minutes in an hour. So we definitely use base 60 in everyday life. Okay, so I'm going to go through a few examples. So let's take 13 base 8, and this is written as a subscript, so we know what base it is, 13 base 8, and we want to convert that to base 10. And again, base 10 is the number system we're used to. So the way we do that is we look at the place values for base 8. So we start with 1 and then 8, 8 squared, and it would continue on and so forth. We don't need that many, but just so you see what is happening. Now notice we have two place values. We have a 1 and a 3, and so those sit in those particular place values, but those place values, that is the value, the numerical value of what they are. So we have 1 times 8 plus 3 times 1. And so we get 8 plus 3, which gives us 11. So if we were counting in base 8 and we got to 13, it would be the same as if we were counting in base 10 and got to the number 11. Another example. So this time we're going to look at a number in base 2 and convert it to base 10. And so we need to look at our place values for base 2. And so they always start with ones, and then 2, 2 squared, 2 cubed, 2 to the 4th. And we put those numbers in their respective places. And then we multiply that number times its place value. So 1 times 2 to the 4th. And we want to add that to 1 times 2 cubed. Plus 0 times 2 squared, plus 0 times 2 to the 1st power, plus 1 times 1. So you might need a calculator on this one. 2 to the 4th is 16. 2 to the 3rd is 8. Anything times 0 is 0. And 1 times 1 is 1. And now we want to add those up. So 16 plus 8 plus 0 plus 0 plus 1, and we get 25. So 11001 in base 2 is equivalent to 25 in base 10. Now what if we want to go the opposite direction? So we have a base 10 number and we want to take it to a different base. So let's look at 38, and we don't write base 10 down here. It's understood if there's nothing there, but you definitely can write it. And we want to convert this one to base 5. So we still look at the place values for base 5. So 1, 5, 5 squared, 5 cubed, and so on. But we need to know the values of these, because this time we need to use division. So in order to go from some base to base 10, we multiplied and added. This time we need to divide. And so we know that this is worth 1, this is worth 5, this is worth 25, and 5 cubed is worth 125. Now, we look to see which place value is the biggest one that would go into the number that we're looking for without going over. So right away we know that we don't need that one, it's too big. And so we're going to have a 3-digit number. So now we want to divide. So we take 38 and we divide it by 25. So how many times does 25 go into 38? It goes in once. So then 38 minus 25 is 13. Now going back to what we had, we know that there's a 1 there. It goes in one time. Now our next place value is 5. So we take our remainder that we had, and now we divide that by the next place value, which is 5. So 5 goes into 13 2 times. That gives us 10. 13 minus 10 is 3. So now our next digit is a 2. And we do the same thing with the last one. So our remainder is 3, and we take our next place value 1. 1 goes into 3 3 times. Nothing left over. So that is our final digit. So 38 base 10 converts to 1 2 3 in base 5. Let's try another one. We want to take our number 56 and convert it to base 4. So let's look at our place values for base 4. 1, 4, 4 squared, 4 cubed, 4 to the 4th, and so on. But we need to know the values of these. How much do they end up being? So 1, 4, 16, 64, and I can actually stop. So I know that this doesn't work. 64 is too big, so we don't need that one either. So again, a 3-digit number. So we need to divide. So 16 into 56. 56, 16. We need to figure out how many times 16 goes into 56, and it goes in 3 times. And so 16 times 3 is 48. And then subtract 56 minus 48 is 8. So our first digit is a 3. The next place value is 4. So now we have 8 divided by 4, goes in twice, and there's nothing left over. So there's a 2, so 1 goes into 0 0 times. So our number is 320 base 4. Now let's try something harder than that. What if I want to go from some base to some other base, but base 10 isn't one of them? So 1 1 1 0 0 1 0 1 1 in base 2, and we want to convert that to base 9. Now the only way that we can do that is to actually take the base 2 number, convert it to base 10, and then take that number and convert it to base 9. So we're using our multiplication and our division in the same problem. So this definitely takes 2 steps. Okay, so let's go ahead and do that. We need base 2 in there. Okay, so we need 9 spaces here. So 1, 2 square, or 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th. Very big number. So we put in our digits where they go. And then we multiply. So 1 times 2 to the 8th is 2 to the 8th. 1 times 2 to the 7th is 2 to the 7th. 1 times 2 to the 6th is 2 to the 6th. 0 times 2 to the 5th is 0. 0 times 2 to the 4th is 0. 1 times 2 cubed is 2 cubed. 0 times 2 squared is 0. 1 times 2 is 2. 1 times 1 is 1. So now we need to add all those up, and so we get 256, that's 2 to the 8th. 128 is 2 to the 7th. 2 to the 6th is 64. 2 cubed is 8, and 2 and 1, and we get 459. So 459 is our number in base 10. Now we want to take that and convert that to base 9. So now we need our place values for base 9. So we have 1, 9, 9 squared, 9 cubed, and we need to know the values of those. So we know that this one's worth 1, 9, 81. 9 cubed is 729. So that's too big because it's bigger than the number we have. So we're going to have a 3-digit number again. Now we need to divide. So 81 into 459. And it's okay to use a calculator on this to just get how much it goes in as a whole. And so that is 5. And so 5 times 81 is 405. And we want to subtract, and we get 54. So our first digit is a 5. Next place value is 9. So we do 54 divided by 9. That goes in 6 times, and that one is even. So that means our ones digits are 0. So 6 and a 0. So our final answer is 560 base 9. So if we look back, our number 11001011 in base 2 becomes 560 in base 9. Okay, so now that you've watched this recording, what you're going to do is call me, text me, or send me a Skype message so we can talk about this recording, and I'll ask you a question or two, and then that will give you credit for this assignment. Have a great day.